Alright guys, so we move on to the next thing, which is simultaneous equations. Now, I'm guessing most of you actually know there's two types. If you don't, I'll be explaining them anyway. The first type is where you've got like what they call two linear equations. And all a linear equation means is that there's no squares, there's no cubes. It's just like x and y, or a and b. There's no power. The only power really is just one. So they're nice and kind of, simplish in a way. And the other one is where you've got one of them linear. Do you see this equation A for this type 2, which I'm hovering around? That's also like a linear one. That could easily be kind of in one of these. So one of them will be linear, and the other one will be tougher. And you usually have like a squared or two squareds. Most of the time, this is like a little quadratic. But basically, one's easy, one's hard. That's basically it. So now, a lot of people generally can be okay on type 1, though a lot of them struggle. I know, especially, this one I've just put plus and plus. But for example, if I had changed that one to a minus, then, when there's minuses involved and stuff, I think there's a few people who don't know which way round. Are you taking one away from the other? Are you adding? And they screw up the sign and they mess it up. And again, that's because they're trying to learn this as a rule. Very few people can do this one. This is like an A-star question. Again, it's, if it comes up, which it comes up regularly, it's usually about 5, 6 or 7 marks. It's huge. It gets you so many marks, but very few people can do it. And again, it's because you don't, a lot of people don't know why they're doing it. So before I actually go into kind of teaching you how to do this one and then how to do that one, I want to first tell you what's going on. Tell you what the situation is with the question. And once you understand it, then that gives you, it gives you a little bit of a path to follow. You understand why you do each step. If you don't know why you do each step, you've just got to hope that you get every step right, that you remember it perfectly, and the questions don't change around, anything like that. So, so let's firstly go through this. The first thing I want to show you is, I don't want to really jump in and tell you this is how you do this one, this is how you do this one. So let's go and look at what the situation is with both of them, and you'll notice there's a huge amount of similarities. So, alright, so the first thing, obviously when you get one of these questions, is you'll have two equations basically. And can you see that both equations have x and y? Either one. It doesn't matter what situation, if it's one linear and one tough one, or even the two linear ones. They've both got two equations which have both x and y. Now, here's the problem. You've got to basically find the x and y, which at the same time solves this one. Wait 1 second. Solves both this one and this one. So you need to find like x equals something, y equals something, and when I plug these values into here, it solves this one, and when I plug it into here, it also solves this one. So that's why it's called simultaneous. It's basically, we're looking at the answers which at the same time, or in another way, simultaneously solve both of these equations. And it's the exact same deal here. Again, we're looking at the x and y. What you'll actually find out later with these questions is that there's not just one combination of x and y, there generally tends to be two. Right? So there's actually two kind of combinations for these ones, whereas there's only one. But basically, it's still simple. If I take this x and y, and I substitute into here, it will work. Basically, 7 lots of that x plus that y will equal 1. But also at the same time, if I take this, whatever this x is, sorry, these look like zeros. What I'm saying is that this could be anything. Yeah, that's what I mean when I do these like little circles. Probably the worst thing to do, circles that look like 0. But yeah, so I'm saying also at the same time, if I take this thing, this number of x, square it, times it by 2, and take away 3, everything that's said here, it's going to just basically equal this number. So again, it's really the same thing. It solves that one at the exact same time. Let's kind of get rid of some of this. So that's what you have to do. That's what you're trying to figure out, basically. And hopefully that's kind of clear to you guys as well now. So right, so what's the problem we have at hand? Well, the problem is this. Like, you know, as we've been kind of, even once we were doing quadratics, where, you know, you get some ugly stuff like this, you know, things like this. So this it might be quite difficult to solve, as we've kind of shown. No, it isn't, but like, you know, it can be. At least we can solve this because at least it's only got x. It doesn't have x and y. Then we've seen even questions like this. Again, not the prettiest, but we can still solve that because that's at least it's still got only x. Both of these equations and the two equations here, they have both x and y. And you can never solve an equation which has x and y, or, you know, basically more than two unknowns. So the first aim, so can you see this? Look, we'll always start with two equations which have both x and y. So, and look, hopefully you understand the question. You need to find the x and y which solve both of the equations. It doesn't matter what type at the same time. So your first goal, because you can't solve either this one, or at the same time this one or this one, is that you've got to basically use these two formulas, or equations, sorry, to create a new equation. Right? So that's your real first goal. You've got to create an equation which either has x or y, but it can't have both. Because we can't solve one which has both. And then, you know, I mean, you kind of, some of you know what the thing is. Again, I'm not going to go over it in detail. But we end up getting to a point where, you know, we times the first one by 5, we end up timesing the second one by 2, or we could have times the first one by 4, the second one by 3. So, you know, we get to a point of this, and listen, I'm going through this really quick. If this doesn't make sense, don't worry. That's a 10, by the way. This one will be ax plus, what would that be? 10y equals 34. And the whole point is we make these equal, and then we take one away. But notice what happens. Then we get like a certain amount of x. In this case, it would be like 7x equals 14. Yeah, don't worry how, if you don't understand why I did that, I'm not actually going over the method. I'm showing you what's happening. But really, so look, two equations with x and y. We do something here to just create an equation where I can just have x. That's important. So that's the next goal. And then obviously I use this as pretty simple here. You solve that equation to actually get your first x. Yeah? And then, so basically you've got your x. And then basically what you do is you take this x equals 2, and then you can sub it either into this one or this one. And if I just take the first one, so 3x would be 6, and it would be plus 2y, I'm still trying to find y, equals 4. And then I can rearrange that and solve that, and later you'll see I get y equals minus 1. So that's the aim. With this one, it works exactly the same thing going on. Obviously the method's a little bit different. So, you know, I will end up kind of like using the first one, and I'll rearrange it to give you that. And then basically, I will sub that in to here, which will give me this. Again, don't worry if you don't know what I've just done there. That's not the point. I'm showing you the kind of like outline. And then, you know, we rearrange this, and we end up getting something like this. Now notice, that's a quadratic. So watch with these questions, every single time what happens is we have these two equations, we do something, and then we get a quadratic. Can you see how this only has x? Yeah? Just like how this one only had x. Obviously only this one's way easier to solve, 7x equals 14. This one's longer. So then quadratic, we've got 3 ways of solving it. We've got the quadratic formula, we've got factorization, and we've got completing the square. And then, you know, you solve that and you'll get your two values of x. Remember how I told you this thing has 2 x's? So then what you do for each one of these x's, then you use one of these formulas. Obviously I recommend you use this one, which is much easier. And for each one of these you'll find their y's. So, and that's how you do it. And finally, obviously, like when you find your x and y, so for example this x and this y, just obviously plug it into the equation which you didn't use to find y, and double check it. Alright? So that's it. I'm going to go over it one more time very quickly. You've got two equations. You're trying to find the x and y which works for both of them. That's why it's called simultaneous equation. You're looking for the x and y which simultaneously solves both equations, right, at the same time. But both equations, it doesn't matter which one, have both x and y in there, so you can't solve them. So then you go do something, and you'll see that the methods are different from both types. But the aim is the same. We're trying to get an equation which has either just x or y. You'll see we can do both ways, and it doesn't really matter which one. With one of them, if you get an equation with just x's, you find your x value first. If you have an equation with y, you find the y value first. It doesn't matter. And then you sub that into one of the original equations to find the other x or y, depending on if you found the x or y. So that's really just the introduction. Once you do these and get the hang of this, very straightforward. And you know, these ones are usually worth, I'll probably reckon, around 4 marks. These ones literally go anywhere between 5 to 7. Alright, once you get the hold of this, these are some of your best friends. You want these to come up. They're easy marks. But, you know, so what do I recommend you get solid with? Before you do these ones, you have to, and I mean you have to, get good with quadratics. If you can't solve quadratics, if you're horrible at quadratics, you have no hope doing these. For this one, you're just going to have to get used to your algebra. I mean, especially dealing with negatives and stuff like that, that would be good. So I'm just going to say, like, general algebra we'll do for this one. That's it. Once you if you're solid at quadratics, this is going to be an absolute breeze for you. So yeah, so the next video, I'll be showing you how to do these, what they call easier equations. See you in that video then.